Question 29 on the Blacktown Boys 2020 trial. The diagram below shows the graphs of y equals 5 minus x and y equals 4 over 2x minus 1. Show that the x coordinates of a and b are 1 and 4.5 respectively. So because they intersect, we just need to make them equal to each other. Y equals 5 minus x, y equals 4 over 2x minus 1. So we can say that 5 minus x is equal to 4 over 2x minus 1. Okay, that's because they're both equal to y, so they're both equal to each other. So I'm going to have 5 minus x times 2x minus 1 is equal to 4. I'm going to expand the brackets. 10x minus 5 minus 2x squared plus x is equal to 4. I'm going to move everything to one side and make it equal to 0. Because my x squared is negative, I'll move everything on the left to the right. So that'll give me positive 2x squared minus 11x plus 9 is equal to 0. I've got a non-monic here, so I'm going to factorize this. 2 times 9 is 18, so two numbers that multiply to 18 but add to negative 11. They are negative 9 and negative 2. So I'll have 2x squared minus 2x minus 9x plus 9 is equal to 0. 2x, x minus 2, x minus 1 minus 9 lots of x minus 1 is equal to 0. So x minus 1, 2x minus 9 is equal to 0. So we can say that x is equal to 1 and 9 over 2, or 4.5. So which one occurs first? That has to be 1. This has to be 4.5. So therefore, x coordinate of a equals 1, and x coordinate of b is equal to 4.5. Okay, question B. Find the exact area of the shaded region. So here, the shaded region is between two curves, between these two curves. So we need to find an integral from 1 to 4.5 of the top curve minus the bottom curve. So the top curve is 5 minus x, and we're going to subtract this one. So area is equal to the integral from 1 to 4.5 of the top curve, which is 5 minus x, and we are going to subtract 4 over 2x minus 1 dx. Now I'm actually going to split this up because I will need to manipulate this. So I'm going to split this up into the integral from 1 to 4.5 of 5 minus x dx. I'm going to subtract, for the same limits, 4 over 2x minus 1 dx. Now it's going to be easy for us to integrate the first half. It's this second half that we will need to manipulate. So if I go back to my reference sheet, let's have a look and see what we need to do there. Okay, so we've got a fraction, here it is, we've already done a question like this before. So in order for us to integrate it, we need to have f dash of x in the numerator. So here we've got our f of x. When we differentiate that, we'll get 2. So that means we actually need to put a 2 at the top. It's meant to be a 4, so that means we need 2 lots of that 2. So I'm going to put a 2 on the outside. And now we can integrate this. Okay, so let's do the first bit. We got 5x minus x squared over 2. And that's from 1 to 4.5. And we're going to subtract 2 lots of, what do we get when we integrate that? We get ln of f dash of x, ln of the absolute value of 2x minus 1, that's our f of x, from 1 to 4.5. Right, let's sub them in. So we have 5 lots of 4.5, which is 22.5, minus 4.5 squared on 2, which is 10.125. I'm going to subtract 5 lots of 1, which is 5, minus 1 squared on 2, which is half, minus 2 lots of ln of the absolute value of 2 times 4.5, which is 9, minus 1 is 8, minus ln of 2 times 1, which is 2, minus 1, which is 1. But we know that that's 0. So we've got 22.5 minus 10.125 minus 5 minus half. So we've got 22.5 minus 10.125 minus 5 minus half, which is 7.875 minus 2 ln of 8. And because this is 0. And because this area, it doesn't tell us what units it is, so I'm just going to write square units. All of that. Square units.